Okay, well, let's do this. So we're on episode 14.
Is that before or after 15?
This podcast is sponsored by Harvest. I use them for tracking work and invoicing clients. You can get a 30-day trial at getharvest.com. Use the offer code RR after your 30-day trial to get 50% off your first month. Hey everybody, and welcome to episode 14 of the JavaScript Jabber Show. This week on our panel we have AJ O'Neill.
Coming to you live from my apartment.
And I'm Charles Max Wood from teachmetocode.com. I'm not sure where the other panelists are. We also have a guest, and that is Chris Bannon from ComponentOne.
Hey guys, thanks for having me today.
Yeah, no problem. So I have to admit, we did record this once, and the line in wasn't plugged into my audio recorder, and I neglected to start my backup recording. And so, yeah, so we're recording this again. So if it feels a little rehearsed, it is, I guess. So, Chris, do you want to tell us a little bit about ComponentOne?
Yeah, sure. So ComponentOne, my employer, we basically build user interface components. We've done it for over 20 years now. And traditionally, we've built user interface components on top of Microsoft technologies. But about 2-3 years ago, actually, we ventured into JavaScript, specifically jQuery and jQuery UI. And I became the product manager for what is now called SVG, which is our complete kit of UI tools for jQuery UI development. We utilize a lot of HTML5 technology and, of course, JavaScript in that.
Right. So do you guys still do the Windows technology components?
Oh, yeah. So, you know, we're still selling and supporting ActiveX components. So we pretty much are still supporting, you know, really ancient legacy stuff. And then also, you know, we have to still innovate and be on the bleeding edge. So, yeah, there couldn't be a broader spectrum here of technology.
Sounds like fun. But you're focused specifically on SVG?
I am. I also focus on our ASP.NET tools, which actually inherit SVG. But yes, that's pretty much my core technology here at ComponentOne.
All right. I'm going to get around to the point really quick for the people who are interested in JavaScript and not necessarily in Microsoft technologies. What we have him here for is we're actually going to be talking about some of the SVG stuff that they use and have written in JavaScript. So, but you know, kind of get an idea of what ComponentOne is about. And then, do you want to talk about SVG a little bit and tell us what's there and how it works?
Yeah, sure. I'd love to. So SVG is essentially a kit of user interface widgets built on jQuery UI's widget factory. And what we try to do is create components that can be used to build enterprise applications, you know, CRUD apps, data visualization apps. So we have things like charting, grids, and we also have, you know, navigation elements and layout managers, stuff like that. But our core knowledge set is in our charting, our gauges, and in our grids. So we have, you know, what you would expect in a desktop application as far as performance and interaction and features. We have that, you know, in the browser written purely in JavaScript.
Nice. So is SVG open source?
SVG has two basically groups of widgets. We have 18 open source widgets that are licensed the same as jQuery UI and jQuery. So it's MIT or GPL, whichever you prefer. They're pretty much unrestricted in what you can use them for. Any project. I'm sure you're all familiar with those licenses. So those are like the menus, tooltips, tabs, accordions, all the things for putting together websites and layouts, stuff like that. A lot of just really useful tools. And then the things that are more data-centric are in our commercial offering. And we license that basically per developer. So it's similar to what you'd find from Sencha in that respect.
Okay. And that's all built on SVG, right?
The charting is all built on SVG. And as well, also the gauges. So we have linear and radial gauges. So all the data visualization components we have are built using some cool SVG libraries. I can give you a little more detail on that soon.
Okay, cool. So I guess the next question is, for those that don't know what it is, what is SVG?
All right. SVG is scalable vector graphics. And what that is it's a way of drawing and programming graphics in markup that defines a vector image. So it's points and connecting points together. So it's polygons and circles and squares. And putting these shapes together in such a markup and format allows you to scale them to any size. So they're very different than raster graphics, where you're defining pixels and you're drawing each pixel. SVG allows you to create a vector-based graphic that can be scaled down, scaled up, and it's going to have the same crispness and rendering at any resolution. So it's a really powerful technology. That's been around a long time, actually, and it's been around longer than HTML5, but it's just now kind of coming of age in the browsers, where they pretty much all support it, and there's some little tricks to getting it to work in old IE browsers too.
Oh, wow. So you can actually do it in old IE browsers?
You can. SVG actually, when it was first proposed, came or derived, I should say, from a spec that Microsoft was working on called VML. So VML is vector markup language, and this spec goes way back. I think it predates XHTML too. So I mean, it's been around, and IE6 even implemented VML. So it's almost the same API. It's almost the same markup that it supports. So all you really have to do, with a couple little tweaks, is change the document type. So from SVG to VML. And yeah, you get all those features. So you can even do like animation, interaction. Of course, you can draw vector graphics on it. So yeah, this technology is something you can use and utilize in modern browsers and really get hardware acceleration. But you can still fall back and still work in IE6, which is just awesome for a technology like this.
Right. That's interesting. So it makes me wonder a little bit then, can you take something like SVG or VML, whatever the technology is, and is it performant enough to like write a game in it?
It can be done for, I would say maybe something like your Pongs and your Tetrises, things that are more shape driven and aren't as point of view stuff where you really need textures, things like that. Yes, totally. This stuff can be very performant to the point where you can do gaming. What I kind of like to break it down for is two analogies. SVG to me is kind of like the Legos, where you have these blocks, like these shapes, and you can actually have them in your hand. They're physical blocks. They're in the DOM. You can inspect them in the browser, see how they look, see how they feel, and you can snap them together and basically build things. So that's very conducive for things like data visualization, charting, graphing, doing infographics, basically where you're drawing these vector-based images. But when you get to the point where you really need to draw something with a lot of detail, basically where you need a raster graphic, that's where I would say you cross over to Canvas. So like traditionally I would say gaming, mostly you would probably stick to Canvas. And the analogy for Canvas is it's more like an Etch-a-Sketch, where you have a drawing API and you have a canvas, and you're just kind of sending your pixels out there onto the canvas, and it's not as much physical pieces like you have in SVG. So it's a little bit weird of an analogy, but it kind of works if you're trying to understand the two different drawing tools in the browser right now and when to use what.
So I saw a demo that was, it looked like a mix between the Windows Maze screensaver and Doom. And
oh, yeah.
So did you see that one too?
I did see that one, yeah.
So in that kind of case, that's a game there where the whole thing, I think, is made of SVG, right?
It's SVG. They're loading in some raster graphics in there too. Yeah.
Okay, so what part of that was SVG? Like with the SVG, can you take something and give it a 3D context like that, or?
That's more of like the 2.5D stuff where you're kind of like skewing graphics. You know what I mean? And you're faking it. You're not doing like ray tracing and stuff like that where you would in a real traditional 3D environment. So yeah, it can certainly be done. There's no doubt. But that one was more of like taking shapes, putting these raster graphics on it of like the walls and the sky and all that, and then skewing them to make the perspective look like it was 3D. You know what I mean? It wasn't as much as a real 3D environment. So it can be done. It certainly can be done. But what SVG is best suited for, I would say, is more of the 2D vector graphics that you want to scale on anything. Like a really good example is like icons. You want to make an icon set that is going to work on a Retina display iPad at the same crispness and rendering that you're going to have on a desktop, that's 72 DPI. That's really where its strength is, not as much in the raster arena.
So that kind of brings up a point then. If you're using an icon like that, something that looks great on like high resolution and low resolution, how do you get that into your web page?
Yeah, so there's a couple ways. SVG can be used as an external file. So just like you would create a PNG or a GIF, you can create an SVG file. And that file can be used like as a object tag. You can put it right in the page and reference an external file. You can also do inline SVG, and that's mostly what we work with. So just like you would create a div tag with some child elements, you can create an SVG tag, and then you can add SVG elements to that SVG tag. So right in the DOM, you can actually build an SVG document. To me, that's my preferred way of working with it, because usually we're programmatically creating that based on parameters. So, and then also with external files and stuff, you can do that in CSS. So background images could be SVG, and imagine you're building something responsive that maybe scales. Doing an SVG document with a background image that scales is very very desirable, because you can have the same size image as far as bandwidth you're sending across, but it actually will scale to fit whatever you want on the screen. So you compare that to like a PNG or a JPEG, and you're going to have like millions of pixels versus just a couple K just to get the definition, I would call it, which is the SVG doc. So as far as doing inline SVG, the way we do it here is we use a library, and the library is called Raphael. Raphael is really handy. It is a drawing API, so it's a JavaScript library, and it gives you a common API in the browser to draw SVG or VML graphics. And you don't have to know which one you're drawing. All you do is use the same API to draw circles, to draw polygons, and basically it's going to do what jQuery does. It's going to do all the cross-browser stuff, so you don't have to worry. You don't have to write the exceptions in there for old IE, and it's just going to work. So, and it's got support for animation. So using all the transforms, you can create sets, so you can group elements, move them around, and then of course you can draw whatever elements you want on the screen. So if you're doing inline SVG and you want to program SVG into your page, definitely use Raphael. We totally depend on that for all of our charting and gauges, and it really has helped us a lot in focusing on just programming the data visualization logic and not worrying about cross-browser SVG.
Yeah, I've heard a lot of good things about Raphael. When I was first looking at it, though, I was looking for a charting library, and it seemed like, I went and looked at it, and I'm like, well, this looks like something I could use to draw anything. And it's not necessarily focused on solving the problem of making a pretty graph. Are there special considerations you have to make when you're drawing the graphs or other visualizations?
Yeah, I mean, just becoming familiar with the different APIs. I mean, if you're talking specifically about Raphael, just becoming familiar with it, how to draw with it. There's some things that we did to extend it. So what we do is we made a couple shape functions. So if you find yourself drawing triangles or say a diamond, it's a polygon. Everything's a polygon there. That's not a circle. So what you're doing is drawing those points. If you're doing it over and over, you can create functions that do that. So you could pass in like the size and maybe the style, stuff like that, to really easily create these common polygon shapes. That's definitely something that can save you time. And other than that, definitely you want to understand transforms and how to do the animations, because if you think about using SVG versus PNG, other than the performance you can get out of it, animation is probably one of the biggest features you have. So you have these drawings that you're doing on the surface of the browser, where you can animate them and bring them to life, and that's definitely something you want to take advantage of because you have it.
So basically, you can make your graph get up and dance across the screen.
Yeah, sure. And somebody will do that. Yeah, it's really, that's one of the benefits is that, it's in the DOM, and most of the new browsers are basically just have tweaked out rendering on that for performance. So it's hardware accelerated in most cases. And you can do some really cool, really fast transitions, very, very interactive applications when you start using SVG.
So when you say it's in the DOM, you don't mean that it's in the DOM in the sense that you have like one canvas element and then you just, kind of change what's inside. With SVG, you make it sound like each part of the graphic is its own DOM element.
Yeah, exactly. That is the big, huge difference between Canvas and SVG. The Canvas is one element. You can't inspect it in the DOM and see what's drawn on it. You know what I mean? It's just basically been painted on, and you don't have access to that when you're debugging and going in and inspecting the DOM in like Firebug or Chrome Developer Tools. So what you can literally do is like go to the Wijmo site, open up a sample, and you can right click on any of the charts and go to inspect element. And you're going to see, the polygon or the ellipse or whatever it is that's drawn on that surface. You're going to see its X and Y offset. You're going to see its style. And you can actually change all those, just like you would changing, the style of a menu or something that you created in a web page. You can tweak it. You can get it to the point where you like it. Take those same properties and save them. So if you really are looking to debug like you would a normal DOM element, all of those pieces of an SVG document are right there in the DOM browser.
So does that mean that you can also attach jQuery events to it? So click events and hover events and stuff?
That's a good question. So one of basically, I would say, it's not a downfall, but it's definitely a hurdle if you want to stick to jQuery. No, it's SVG and its inner elements are not all supported in jQuery yet. I know it's something on the radar, but it's not there yet. So Raphael gives you an API for that. It has an events API. So yes, you can do hovers, clicks, using the Raphael syntax. But jQuery itself, no, not yet. And you can also extend Raphael as well. So like we did an add class feature since we class all of the elements that we put in so that you can access them via CSS or JavaScript more easily. So each thing has each chart has a class system. So you have, say, a pie chart. You have like slices as a class, and you can access those through CSS. So to do that, we added a little add class, has class, and remove class set of functions to be able to do that. And that's very easy to do. So the short is jQuery doesn't yet support it. Raphael does, and you can easily extend Raphael to add similar things that you'd find in jQuery.
That makes sense. Of course, I have no class, but that's a completely different problem.
Yeah, you can't add class to programmers. We've tried. It doesn't work.
They either have it or they don't, right?
Yeah, nor should you.
All right. So I'm just looking over some of the stuff we talked about before because there was so much there.
So there was something I don't know whether I shared before or not, but so there's this image, I'm looking at it right now, with a wrench, and as you hover over the wrench, it shows in a table the different parts of it. I'll send you the link in just a moment. But I'm kind of curious to understand how that works in SVG. So give me just 2 seconds here, and I'll have this over to you.
So this is a SVG element in a browser that you're looking at?
Yeah, so there, I pasted the link here. Take a look at that and
cool.
Explain this to me. Because this kind of fits in also with that idea of like events in the DOM and whatnot. How is this thing working?
Yeah. It actually, this doesn't look to be using Raphael, no. So this is something that looks like was just basically written in pure SVG. It's itself is a document, and it has grouped elements. The groups is a way of kind of it's a way of grouping. Yeah. So what you do though is you can add a G element inside an SVG, and that is a group. And then anything you put inside of that is a group. So it's an easy way of applying events to a group, and they'll bubble up from all of its inner elements. It's an easy way of styling. Also, you can style groups. So what's happening here is they have the wrench pieces are in a group, and it looks like they are adding some handlers, event handlers, which are basically JavaScript. And what they're doing is highlighting a row and what looks like a table. It's not a real table, but it's a drawn table in SVG. So it looks like an HTML table, but it's not. And what I think, are they in the same group? Like the table row may be in the same group as the piece that it's correlated to. I'm not sure. I can't quite tell. But basically that's it. So this is a really cool example of what you can do in SVG alone. So there's really no outside forces, working on this as far as a bunch of script written or anything in the page. It is just this is an SVG document that has interaction programmed within itself. So
I'm actually just opened this up here, and it does have a script tag in it. But interestingly enough, it's marked as ECMAScript rather than JavaScript.
Yes. Yeah, I think you could do the same with JavaScript here.
Well, I mean, JavaScript is ECMAScript, but it's interesting that, I don't know, is that something you have to do in SVG? If you use script, you have to call it ECMAScript instead of calling it JavaScript? You know?
No, I think if you just change the ECMA to JavaScript, it should still work, but I don't know.
Okay.
I'm going to defer that to the browser vendors panel, who really has been silent this whole time. I don't know why they're not answering.
They don't want to get in the same room with us.
Yeah,
because then coherent standards would happen, and that's just that's not how they roll.
They're just quietly observing here as panelists, aren't they? They really
just making sure that if we say anything intelligent, they do the opposite when they standardize it.
There you go.
Yes. Yeah. So I don't know the answer to that. I mean, we can try it.
Yeah. Speaking of silent panelists, Joaquim just joined us. So
welcome.
So yeah. Anyway, sorry to interrupt, but yeah. Heaven forbid the standards bodies do anything intelligent.
Yeah.
So I had another couple questions for you. This one's just kind of out in the blue. But how does SVG relate to fonts?
Because
like fonts are also a scalable vector format, right?
Yes, they are.
So how is a font and an SVG similar, and how are they different? Do you know?
Well, I mean, obviously a font, it can only represent characters, like in text, right? So, I mean, that's a given. But
there's like Unicode fonts, like Steaming Pile of Poo, for example, is one of the latest ratified Unicode fonts.
Yes. Yeah, but again, you have to have the character, right, in the markup in order to get that. So in some sense, you can only represent something that is a character a Unicode character that the browser supports. And sure, you can make a custom font, but I promise you that it's easier to just draw a vector graphic than it is to write your own font. For most developers, I would say. Like
on Android, like a year ago, you had to use SVG in order to do fonts in a web page. Like the format you saved a font as was SVG, and now the format you're supposed to use is like WOFF, I think, the Web Open Font Format.
Yeah. So I mean, I guess the SVG they're using there was just a way of defining a vector font face. I don't know, honestly. Okay. But the weird thing is that SVG itself, like inline SVG, wasn't supported in Android then. So that was a little backwards. But I don't know the differences technically in what Android was doing there but I imagine, you're just defining the font characters in the SVG. And I mean, they each have their purpose, and there's people doing the icon font faces now, which is definitely cool stuff. That has its uses for sure. I would say that you're going to get a lot further with SVG, though, in most cases. But the font stuff has its place.
So you mentioned, and I'm going to kind of go off on a tangent here real quick, but you mentioned like SVG in the mobile browsers, like in Android. Is SVG supported across the board in mobile browsers, or?
No, it's not, unfortunately. It's pretty solid. The real exception in mobile browsers is Android browsers older than the latest and greatest release. What is it? Ice Cream Sandwich?
I think so.
Ice Cream Sandwich is the latest. So that has SVG support finally, which is awesome. So, anyone that goes out and gets a new Android with a new OS will have it. But you know how many people are out there with, Gingerbread and who knows what version of Android that you have to figure out how to support that. And you can't do VML, you can't do SVG, but you can do Canvas. So there are some little libraries out there. Fabric.js is one, and that lets you interop between Canvas and SVG. So there's an API for basically parsing an SVG document and drawing it on the canvas. So it basically translates it into how you would draw it on a canvas. Obviously, once it's drawn on the canvas, it's no longer scalable. But if you're looking to do something like take SVG that you've already built and just make it work on an Android, that is a way of doing it. So,
how big can you really scale on an Android anyway, right?
Yeah, that's true. The scalability, I mean, it's not that big of a deal once you've drawn it. But for generically building applications, the scalability is nice. I've seen some people start experimenting with like whole app frameworks in SVG, which is pretty crazy. Like if you would think about something like what Flex or Silverlight have done, where they're essentially SVG on steroids in a plugin, right? It's just all vector drawing that you do, and they have a control concept and stuff like that. But that's just all sitting on top of a vector drawing plugin. That's all they really are. So essentially, with some JavaScript and the SVG, you could build like a framework like that where you have interface components and it's all drawn in SVG. So there's some crazy people out there doing that, which is really cool stuff. I don't know that that's necessary personally, just because the HTML is much better suited for a lot of that. But I can see it. I can see a niche there that would be pretty neat for building an app framework there. But that's a edge case.
So what's the coolest thing that you've seen done with SVG in the browser?
Oh man, Wijmo, clearly.
Oh, of course. What am I thinking?
While we're on that topic, so there was something we talked about last time when we did this that I wanted to bring up again, like the importance of good visualization, right? Because we talked about the Challenger explosion and how that was caused by poor visualization tools.
Yes, yeah. The question was asked of what makes good data visualization, and my answer was good developers make good data visualizations, and what I found, just working with a lot of customers, myself included, of Wijmo, and how you're building data visualizations with your bare hands and the tools that we provide. The key is to understand the data and understand what value you can portray with the data. And a perfect scenario of data visualization gone wrong was the Challenger explosion. So there was a report given to the people deciding whether the temperature outside was okay to launch at. So taking into account the basically Fahrenheit outdoors, what the safe area is, and what the ratio is for failure at different temperature levels. And the visualization did not represent the data well, in that it didn't show the most prone temperature first. I think it grouped them chronologically. So you had to look through all these things chronologically to find incidents of mechanical failure. And then you had to figure out what temperature that failure happened at. So that it really was just not thought out of what you're trying to represent and the message you're trying to convey with data. And, what happened was that cost people's lives. So it's a very dramatic story, but it's a perfect example of you have to really sit down and think about what you're trying to portray with your data visualization before you just go and throw your data in a chart. You know what I mean? And it's something that a lot of, I think, developers don't really think through. And of course, not all developers have, a business analyst or someone that has that knowledge. So we kind of have to take it on ourselves to really understand the business behind the data before we can do good data visualizations.
And I don't know if we mentioned this last show or if somebody else was showing me, but there's also one of the news channels had a pie chart where it showed like Obama had a 60% approval rating, and who was the woman from Alaska that had like Palin? Yeah, Palin had also like a 63% approval rating, and like somebody else that had a 50% approval rating. So you have this pie chart that adds up to like 160% or 170%.
Yeah, that's like, I would say the any news coverage of politics is classic examples of bad visualizations. But here's the gotcha. So the Challenger explosion was just a case of poor data visualization in a sense that whoever built it didn't really understand the purpose of it.
It wasn't on purpose. It
wasn't on purpose. But you have bad data visualization that can be a very evil and useful tool. People can take data visualization and use it for evil, and people do. And when I say that, I mean they can take data and do things like omission of data, do things like manipulating the axes, and that can give you a very different visualization than what the actual reality is. So a pie chart that adds up to more than 100% is a very good example of that.
My favorite
that's
example,
just illogical.
My favorite example is the original Pentium 4 versus Pentium 3 chart in like one of those tech magazines. So it shows like the performance, and so the Pentium 4 is running at like 1.2 gigahertz, and the Pentium 3 is running at like 800 megahertz. and then they've capped the chart so that there's that little squiggly, and so it looks like performance-wise, the Pentium 4 is like way above. But then when you zoom out, the 800 megahertz Pentium 3 is like 10% less powerful than the 1.2 gigahertz Pentium 4.
Oh, right.
Yep.
So you set your minimum so that it looks like, the Pentium 3 is like at the rock bottom of the chart.
Yeah, and really, it's 400 megahertz faster and only has like 100 megahertz gain.
Right.
Yeah. You can do all kinds of stuff. There's a blog I can link to that kind of finds these just blatant bad visualizations or evil visualizations, and kind of calls them out. And actually they always look up the real data that it was based on. And almost always it's like, government data that's public, so you can get it. And usually, whatever bureau is publishing it, they actually publish the real chart with it too. So you can literally compare them and see how blatantly bad they are. But it's very amusing stuff. So beware. I mean, it's your visualization could be, costing people jobs or causing people to make bad decisions, and you just keep that in mind. It's so easy to misconstrue data in those visualizations.
So if I'm using a tool like Wijmo, what kinds of things should I be doing to make my data visualizations better, assuming I'm not this malicious person trying to tell my own story?
I mean, just the most common stuff is keep an eye on the accesses to make sure you're not skewing the data by having too wide of a range. And then B, make sure that if there's a difference, make sure it's very clear what the scale of that difference is. So let's say we're looking at like page views or something for two different websites. And we'll say the website A has 300,000 page views a day, and website B has 400,000 page views a day. So that's a huge difference. 100,000 a day. That's very significant. But let's say that when we're drawing our y-axis labels, let's say we start the bottom at 0 and the top at 1 million. When you draw those, they're both going to be, about a third of the way up, and they're almost going to be on top of each other, right? So you're barely going to see a difference between the two, and you're going to say, oh, well, they look like they're pretty even. That they're both at this roughly the same page views a day, because you're not going to see that there's 100,000 page view difference a day. So what you would do then is start the low end at maybe like 200,000 and the high end at like 500,000. And then you'd get the picture of just how big of a difference it is between the two. Mm-hmm. So watching your axis is a very important thing to do. If you're doing date time stuff, definitely make sure that, like in a timeline scenario along the x-axis, you want to make sure that it's very clear. Like say you're missing a month, you want to make sure that that's spaced out either chronologically so that there's a gap there, or make sure that there's labels there and some kind of indicator that you've omitted some kind of time, and this isn't a linear timeline. So that's another one that can be very misleading, and you'll see that in a lot of the political ones too. That's very common. So I would say that the biggest thing is just watch your axes and make sure you're very clearly indicating differences between your series. And then also time is another big thing to make sure you're conveying properly. Because usually what people do is they'll look at the first one or two labels and they'll make an assumption that the rest are like that. So you just be aware of that.
Right. That's one thing that I always think is interesting is that people, when they're pulling these numbers together, they'll actually like yank out the stuff that doesn't say what they want it to say because it's, quote, statistically irrelevant.
Oh yeah. That's another
This person's an anomaly because he likes the other party.
Yeah, but, that's tough. But what are you gonna do? That's the reality. So just be aware.
Yep. Well, cool. Well, we're really right on track with where we want to be. We have another 5 minutes or so before we need to get into the Pics. Is there anything else that we should know about SVG that we didn't think to ask?
I'm trying to think of the previous previous recording, and like I think we covered most of the same big topics. I think we've covered it. My biggest point would just be to go out and try SVG. I just hope that everyone understands that it's probably one of the greatest tools you can use now for doing graphics. And anytime you're going to draw icons, anytime you're doing something that might need to be drawn on a mobile site different than it will on a desktop site, consider SVG. Anytime you're doing visualizations, consider using SVG instead of just saving and outputting a PNG or something like that. Of course, we'd love you to try Wijmo, but I hope you try SVG in general. Keep an eye on it. Play around with it. Here's something we didn't touch on, and if you really would like to get started quickly in using Raphael, there is a website that is for converting an SVG drawing into the JavaScript, what you would need to draw it with Raphael. So that's just awesome. So you can open up Illustrator or anything and start throwing shapes on there, and you can save the file as SVG. Then what you do is you upload to this website, and it's going to give you back the Raphael script that it would take to draw that. So that's a really nice way of saying, oh, here's what I want to draw, and then here it is in SVG markup. And then if I go upload it to this site, I can see what programmatically it would look like when I'm drawing it. Now, obviously, you can tweak the programming, but you'll get that kind of conversion path, and you'll understand which way it goes. And vice versa, if you draw something in Raphael in the browser, you can actually right-click on most SVG elements in most browsers and save that as an SVG graphic. So you can save it to your desktop. So when we were doing these charts and gauge development, what I would do is I would kind of get it to a decent point. I would save it to SVG, send it off to our designer. He would open it up in Illustrator or whatever tool, tweak it to his liking, send it back to me, and then I would basically consume that and make modifications where I needed to. So it's a really nice way of sending SVG back and forth between different developers, designers, and understanding how it goes from SVG to the JavaScript programming in Raphael and vice versa.
That's really cool.
I came a little late to the party, but I was wondering, could you recommend any learning resources? And how did you yourself come to learn about SVG or become an expert?
Well, I'm not an expert. Let me make that very clear. But I do love SVG. I would say I'm like an SVG fanboy, if anything. It's very underutilized, I think. So I first came across it. My gosh, I would say like 2005-ish, maybe, just screwing around with different stuffs in a design and seeing some. I think I saw a blog post where somebody was experimenting with it from the W3C. One of the SVG guys there, and I just thought it was such a cool thing to be able to do in the browser. And a lot of companies have been using that VML stuff for things like mapping for a long time. So I saw some other cool stuff there in mapping, and they were using that in like IE6 and doing some crazy desktop version of IE6 in their desktop apps that used SVG. So that kind of is where I got the taste for it. Honestly, a lot of learning it was just by getting into the markup and seeing what did what. There's not any resources off the top of my head that I can recommend other than Raphael and the documentation and samples there. Definitely check that out, but that's geared more towards programming it in JavaScript. If you go to W3C's SVG site, you're going to see a lot of samples. There's like the classic quintessential SVG sample, which is the roaring tiger. I'm sure you've seen it. That one's fun to just inspect it and see what's going on and how you build it. And again, just opening it up in a text editor and changing stuff and seeing what happens. And it's not hard to understand once you start playing around with it and messing with it. It's just like HTML. It is in a sense. So I can't give you any resources. I could look some up maybe and link them, but for the most part, it's just experimenting. That's how I came about it.
Fair enough. Cool.
Cool. So one other question I have that just kind of occurred to me is, what instances do you think Canvas may be a good fit that SVG isn't?
Definitely 3D gaming. You should be using like WebGL for that and looking at Canvas. Definitely raster drawing. So working with photography and stuff like that. There's some gotchas, and these are so general, but I would say that's the key. So anytime you want to do raster stuff, like, and I would consider most gaming, as in games I'm familiar with and play, is texture based, raster based, where you're doing a lot of drawing pixel by pixel. You're doing ray tracing, stuff like that. Definitely Canvas there. I think that's probably it. Maybe I want to say kind of like things that are live and hooked up to like constantly changing data, but it's not really true, because like we have like streaming charts we've made like using WebSockets that like literally are like live drawing from the server. So you can do that in SVG. The difference is that you're redrawing the whole document versus just, with Canvas, you can just draw whatever pixels you want on there. Right. So I want to say that, but I don't, because you can do both. So for the most part, it's just when you're working with raster stuff, gaming mostly, do Canvas. And then when you want just like SVG icons, drawing charts, visualizations, things like that, check out SVG.
All right, cool. Well, let's go ahead and get into the picks. AJ, what are your picks?
My pick is most assuredly Chris's profile pick.
Oh, nice.
Because it is
nice.
Fierce.
We're going to have to link that, I think, if you're going to pick that. I might have to send you guys a link to that one. It's bad. That one, just to explain, we were doing like a photo shoot just because somebody needed a picture for an article or something, and we just turned it into a total joke. So we pulled out Blue Steel and Magnum, and they ended up, the communications go here ended up sending one of those, so it's now all over the web.
Right. Any other picks, AJ?
I wish I could remember what I talked about last week, but I did finish reading Catching Fire just last night of the Hunger Games series. And I think that book was actually more engaging than the first. Once you get past like the first couple chapters, because there's like a lot of repeat info from the first book, which I think is really annoying. I like the style where they just take you into the story, they don't tell you all the backstory, and they let you go. But when you've read the first book, and the second book's first couple chapters are a recap of the first, it's like, But other than that, very engaging. Loved it.
All right, cool. Joaquin, do you have some picks for us?
Yeah, I do. I had some really, really funny and interesting ones last week, but I'm not really in a funny and interesting mood this week. So instead, I'm going to give a shout out to Google Wallet, because I don't do banking stuff. I got burned by PayPal, and I hate them now. But what happened was I saw a link in my Gmail account about I can call phones and stuff like that, and I clicked on that. And I was like, oh, I can put in some money there and call cheaply. And then I had to set up my my debit card with the Google Wallet. And my address is in Thailand. And there was this whole thing with drop downs and Thai script. And it was horrible. And I tried 3 times. And then my account got locked. And I kind of resigned myself to never being able to use Google Wallet again, because I was not going to scan 50,000 documents and send it to them. And I sent an email to them and say, hey, I got this problem, and maybe you guys should fix how addresses are entered. And I got an email back 3 days later, and they said, we've looked through the account, and your account is active, and your debit card is now connected. Which is, I've never seen service like that before from any payment merchant. Awesome.
Nice.
They just fixed it, Normally, they don't fix stuff. They want you to you need to push through these barriers where you can go higher and higher up until you get someone who can actually make a decision. And here, apparently, they figured out how to do that for themselves, which is awesome.
Nice. Awesome. Any other picks?
I've got a link for JS Fiddle, which might be useful for some. Because sometimes JS Fiddle can be, it's a JS Fiddle for using Raphael, which we'll be linking to. That's it.
All right. I'll go ahead and go next. So I'm also not going to pick what I picked last time. I was listening to Geekbeat. I don't know if you guys follow their videos at all, but I think some of them are interesting. And I really enjoy them. They do cover a lot of interesting tech stuff, and they have a lot of cool tech toys that they talk about there. So Geekbeat's one of my picks, and then the other one is one that I found off of Geekbeat, and it's this Google Maps Cube game, and you can get there at playmapscube.com. And anyway, it's I played it for a little while, and then I decided that I didn't have time to play it, but it was a nice reprieve from writing talks for conferences, so I'll put a link to that in the show notes. Basically, it just follows your mouse around, and it's sort of like pinball, I guess. And so you're trying to figure out how to get this ball to roll to the different points in the different cities that you're in. And one of them's actually in a mall, and so you're rolling it through the map of the mall. Anyway, it's really cool. So go check it out. And those are my picks. So Chris, what are your picks?
I have a couple from last week I'm going to stick with, but I think the music I've been listening to is Bass Drum of Death, and I've just killed their album, so I'd love them to put out a new one. That would be awesome. They only have one album, but it's really good music when you're just heads down and just want to write some code. It's awesome. That's my pick for some good developing music. There's a book that I just finished called Directive 51, and I mean the book was pretty good, but it was more of like how it made me think and every day now about my role in the world, and the book was about basically these terrorists take down technology in the whole world. They have like this nano swarm that just eats away at computer chips. So anything at all that had any computer electronics in it just was destroyed and eaten away. So it just makes you think, like, in the world, what you do, like what do you do that isn't with technology and that isn't with working with information that's not physical. And it's like, it's really neat because all the bankers and the people that were the highest paid and the most valued in society became the lowest because they didn't have any, physical skills where they could sit down and build something, like a house, things like that. So it was really, really interesting if you're a technology worker to read it and think about the world and how dependent we are on this stuff. And, it's amazing stuff, but it is so it's crazy to think about. So I highly recommend that. The Inventing on Principle talk by Brett Victor is another pick. I won't even talk too much about it. Just Google that, watch the video. I'm sure we'll link it. It's just so inspiring and so awesome to watch. And my last pick is urban chicken farming. And since I last talked to you guys, I went to my mother-in-law's school where they were hatching chicks, rescued a baby chick that was trapped in an egg, and we have since adopted it and named it Douglas. So we now have a chicken living at our house, and I have found that there is apparently a trend called urban chicken farming that is happening right now in the U.S. So that's my picks.
Can they be housebroken?
No, they have to be like outside. He's like tiny though, so he's in our house and he's in a little cage. Really, he's like a little cute little fluff ball right now, but he'll be a big ugly chicken pretty soon, I think, and he'll be in the backyard.
Personally, I find like ducks a little bit more charismatic,
Oh yeah, definitely.
I have several neighbors.
They have more attitude though. Ducks will come at you.
Yeah, but I actually have a chicken here because I live in Thailand. I live out in the middle of nowhere in Thailand. So we have one chicken that we have here, and it's I don't know, it's just lacking personality. It's a shame.
So what's life like with the chicken? I need to be prepared for this.
Well, they because they cannot be housebroken, as you pointed out, or at least I have not managed to housebreak any of them. So they basically walk around and leave stuff for you to step in. And other than that, they lose their feathers. They have dust. They have like a dry skin and stuff like that. They're made for eating, dude. That's their best use.
Yeah. Yeah, I figured. One day Douglas might have to be a delicious
but they're cute when
meal.
they're small. But all babies are cute when they're small. That's the problem, But
Oh, I know.
You might rename it to dinner.
Ducks, on the other hand, I kind of dig when they're big.
Yeah.
Yeah, I have several neighbors here, and we're not in the middle of nowhere, that have chicken coops in their backyards, and they keep them for the eggs and stuff. And I'm not that brave. I would forget to feed them, and they would die. So anyway, let's go ahead and wrap this up. Thanks again for coming, Chris.
Sure, guys. I really